This is chapter 4.8, exercise 1 through 10. Section 4.8 in our book has to do with using trigonometric ratios for real-world distance calculations. And so I'm going to go over the workings of these problems, number 1, 3, 5, 7, and 9, and leave the even number problems for your further rehearsal and practice. The angle of elevation at the top of the Ulm Cathedral from a point 300 feet away from the base of the steeple on level ground is 60 degrees. Find the height of the cathedral. And we're going to be introduced here to a bunch of real-world phrases or expressions, and in this case, the one we're going to be using is this one, angle of elevation. We're going to also see angle of inclination, angle of depression, angle of declination, and so we're angle with horizontal, a lot of different ways of saying this. And what we're going to be looking for is the height. So the height of this cathedral is going to be this distance here that I'm pointing out, and what we're looking for is an equation where we have one unknown, and in this case we're trying to find, relative to this 60-degree angle, the opposite. And we are given 300 feet, which is our adjacent. And so our trigonometric ratios that are going to be helpful to us are either this one, where the tangent of an angle is equal to our opposite over adjacent, or cotangent, rather, is equal to our adjacent over our opposite. In this case, what you look for is the version that gives you your unknown in the numerator, and I think it's going to be tangent. So our tangent of our angle of elevation, which is 60 degrees, is going to be equal to our opposite side, which is our unknown h, over our adjacent, which is 300 feet. And solving for h, if we cross multiply this 300 over to the other side, we get h is equal to 300 times the tangent, 60 degrees. And that's going to be an easy one on our calculator. So we go get a calculator page, and we put in 300 times tangent of 60 degrees, and for that we get 519.615. So we're going to round this to the nearest foot, which would give us 3 significant figures. So we go back here and we put in h is approximately equal to 620 feet. I think that's it, isn't it? There's 520 feet. Yeah, 520 feet. Let's go fix that. So about 520 feet. And then we go look and see if this makes sense. Okay, well, if this is 300 feet in the horizontal, then 520 feet seems like it could make sense. One thing also, this is a special right triangle, so if we could, since it's a 6-degree angle, 60, 30, or 45, we could have used this side here as x, and the height we could have called x square root of 3. So we could have gotten our answer by saying 300 times square root of 3. We'll do that in the calculator. 300 times square root of 3. You're going to see the same thing here. So there we go. Special right triangle application. But most of these, as you're going to see, are not special right triangles. our special right triangle we could have gotten from our ACP formula chart here. Okay, let's go to, I want to just mention problem 2 briefly, in that we're given this angle here in DMS. Well, to work this problem out, which is very similar to problem 1, we have to convert this DMS into degrees, which we'll do by taking 34 degrees plus, we take that 13 minutes over 60, because we get 60 minutes per degree, plus we convert our seconds into degrees by taking 12 over 3600. So then from here, having calculated this, we can work out the rest of problem 2. Next, problem 3, the angle of depression. Okay, another phrase here, angle of depression. We had angle of elevation in problem 1. This is angle of depression. So this is going to be it right here, 10 degrees. Not to scale. This actually looks like more like a 30 degree if it's drawn to scale, but we get the idea. And we're trying to find the buoy from the lighthouse, and really we have to say that that's probably going to be this horizontal distance. So I'm going to say distance here. Okay. And this side here is also going to be 10 degrees. We have a line cutting through, transversal, cutting through 2 parallel lines. And so again, we have, relative to this 10 degrees, this side here, our distance is going to be our adjacent side, and this side over here, 120 feet, is going to be our opposite side. And just as in problem 1, we can use our tangent theta is going to be equal to our opposite over adjacent, or cotangent theta is equal to our adjacent over our opposite. Now this side, we're going to be trying to solve for this adjacent. So the one that's going to work best for us would probably be cotangent. So we could say cotangent of 10 degrees is equal to our adjacent side, which we're going to call our distance, over our opposite, which is 120 feet. And as we did in problem 1, if we cross multiply that 120, our distance is going to be equal to our 120 times cotangent of 10 degrees. Now going back here, we have 120 times cotangent of 10 degrees. So that's going to be 680.554, and rounded to the nearest foot is going to be 681 feet. That's going to give us 3 significant figures. So one thing you could do also is using the principle that you have 180 degrees in the internal angles of a triangle. This angle up here is going to be 80 degrees. So you could have also said, well, our tangent of 80 degrees is equal to our distance over 120. And so, and tangent of 80 degrees is the same as the cotangent of 10 degrees. So that's another way of solving this problem. And just should make sense that if you're going to have a 10-degree angle, it's very scant. You're going to have a great, the distance, horizontal distance can be much greater. You've noticed so far that we've used cotangent and tangent. Cotangent and tangent seem to be used more often on these types of problems. Again, problem 4, we're talking about angle of depression. I think that's problem 3. Problem 5, a guy wire. Okay, guy wire is you've seen antennas. You see these diagonal wires that hold up these tall antennas. So anyway, we're being asked 2 things here. We're being asked the length of the wire and the height of the antenna. Okay, so what we have here is similar to problems 1 and 3. We have a height, actually problem 1. We have a height that we do not know. We have an adjacent here equals 20 feet. And our height is going to be relative to our 80-degree angle or opposite. Now, 80 degrees is not an angle of a special right triangle, so we really can't use it like we did explore briefly in problem 1. And then we want to find our hypotenuse as well. We don't know what our hypotenuse is. So we really have a choice. I think just because we did it with tangent earlier, we're going to use tangent again. This time we have our tangent of our angle of observation, 80 degrees, is going to be equal to our height over 20 feet. And cross multiplying, we have height is equal to 20 tangent of 80 degrees. And we can go to our calculator. 20 times tangent of 80 degrees. We're going to get a height of 113.426. Okay. That's going to be units of feet. Now, you might have noticed that I didn't round off much, right? I just gave, you had 3 significant figures plus 4 places beyond the decimal, so 6 significant figures in all. Why did I not do that? Well, the reason is that we have a further, usually you want to round off after you have a final answer. In this case, we're going to be using this final answer, this preliminary answer, to also help us find the hypotenuse. To do that, we can use the Pythagorean Theorem. We can use a squared plus b squared equals c squared. So our a would be like our 20 squared. Our b would be our 113.426 squared. And that's going to be equal to c squared. So c is going to be equal to the square root of everything on the left. So c is going to be equal to square root of 20 squared plus 113.426 squared. And so we go to our calculator, go to, there we go, 20 squared plus, I'm going to get the last answer calculated by pressing Control, negative sign, which gives us ANS. ANS is the last number calculated, which would be this 113.426, and we get 115.175. Okay. So our guy wire .175, and around the nearest foot, I'm going to call it, well, I'm going to call it 0.2. And we realize that this kind of angle, our guy wire length is not much greater than the height of that antenna. So we're going to box in our guy wire length here as a correct answer, and also the height. 113.426 feet is a correct answer. Next, okay, I don't think there's anything particularly, 6, you need to draw the picture of that. 7, the angle of elevation of the top of the TV antenna mounted on top of the Eiffel Tower in Paris is measured to be 80 degrees, 1 minute, and 12 seconds. And again, we have this DMS thing. So we're going to convert this to degrees by saying that'll be 80 plus 1 minute converted to degrees by dividing by 60 plus 12 seconds converted to degrees by dividing by 3600. And we're going to get an answer here. We're going to get 80 plus, we had 1 divided by 60 plus 12 divided by 3600. And for that, we're going to get the improper fraction 4001 over 50. And to get this thing decimalized, we have 80.02 feet. So we come back here, we have 80.02 feet. Now it's interesting that they're using feet here, whereas in France, I believe it's meters they use. Anyway, now just to draw the picture, the picture's going to look a lot like that antenna one back in problem 5. So we have the Eiffel Tower, which looks, if you know what the Eiffel Tower looks like, it has this kind of general shape. And from the center of the base to the point that's measured here, we will say this would be 85 feet, or 185. It's 185 feet, and we want to know the height. The height all the way up to the top of that the tower plus the TV antenna. And again, we have an opposite that we're trying to find out, and we have an adjacent that we already know. So what ratio is the best for this? Well, tangent. Look how often tangent is used. A tangent of, we have, well, I had the units messed up, didn't I? I said 80.02 feet. That's not feet, is it? It's degrees. So tangent of 80.02 degrees is equal to our height over 185, and then our height cross multiplying is going to be equal to 185 times the tangent of 80.02 degrees. And going to our calculator, we have 185 times the tangent of 80.02 degrees. And so we get a height of 1,051.33 feet. And rather than there's foot, that's going to be 1,051 feet. Sounds like it's about right. And you notice in all these answers so far, I've put the little squiggle equal because it's just a recognition that this, having used a, having found an irrational number, which would be the tangent of 80.02 degrees, is going to be an approximate answer. Next, this one here, 8. You have a cast of shadow, and we have the sun's angle of elevation. And so this angle of elevation from the tip of the shadow up to the sun, crossing the tip of the smokestack. Problem 9, we have to measure the height of the cloud, you place a bright searchlight directly below the cloud and shine the beam. So we have this cloud up here. I'm going to make this yellow cloud. And we want to find, when they say the height of the cloud, I really think they mean the elevation of the cloud. Because the height would be like what would the height of this cloud be? But we're interested in how high off the ground it is, really. And so we're going to call this, again our height. We don't know what it is. And we have an angle of elevation. So here we have an angle of elevation going up to the cloud. And to complete our triangle, we drop a line perpendicular to the ground like this. There we go, we made our right angle. And this is going to be 100 feet down here, which is going to be our adjacent side. Our height is going to be, surprise, our opposite. And the way I drew this, I mean, it's the same height as over here, so I drew the height over on the left side, which I don't think should be a problem. Instead of drawing the height over here on the right side, I drew it on the left side. Shouldn't matter, right? Anyway, it's the same type of thing, but we have this angle in DMS, so that's going to be 83 degrees plus 12 over 60 degrees. And that's going to be, going to our calculator, 80 plus 12 over 60 . 401 over 5. Is that the right one I used here? No, 83. Okay, 83 and 12. Let's try that again. 83 plus 12 over 60. That's what we get. Improper fraction. Press Control Enter. We get 83.2 degrees. So we go here. 83.2 degrees. And again, we have the tangent of 83.2 degrees is equal to our height over 100 feet. So cross multiplying, height is going to be equal to 100, tangent 83.2 degrees. So going to our calculator, we have 100 times tangent plus times tangent 83.2 degrees. We get round of the nearest three significant figures, we'll get nearest foot 839 feet. So we say 839 feet off the ground, and I think that's going to be right. That really makes sense. Okay, now working the odd number problems are what we're doing in this video lesson, but I just want to look at 10 briefly. You have a ramp leading over freeway overpasses 432 feet long and rises 32 feet. And so you have this ramp. The ramp is going to be going up like this. Okay? And this is 432 feet. And you have a height rising like this. You have 32 feet. So what you have here is this kind of triangle for a freeway ramp. And I'm just going to point out that, are we talking about opposite and adjacent like we did for all the problems 1, 3, 5, 7, 9? No, we're not. This is going to be our hypotenuse. So take that into account as you work out problem number 10, and good luck on the remaining even number problems as well. And thanks for viewing.